consecutive interior angles theorem, which told me that if I have two parallel lines and I come in and I cut them by a transversal, then the consecutive interior angles, so they're the angles on the same side, will add up to 180. And then the converse, so the consecutive interior angles converse says that if I have two lines and there's a transversal and these angles add up to 180, that means the lines are parallel. So again, these two things are just going, you start with parallel lines, you get supplementary angles, you have supplementary angles, that means you have parallel lines. Okay, so the alternate exterior angles theorem tells us that if we have two parallel lines and they're cut by a transversal, then we'll have alternate exterior angles that are congruent. So angle 1 will be congruent to angle 2, and angle 3 will be congruent to angle 4. And then the converse is that if you have two lines and then the alternate exterior angles are congruent, that means the lines are parallel. So again, they're just going parallel gives you congruent angles gives you parallel. Perpendicular transversal theorem tells us if I have two lines that are parallel and I have a line that is perpendicular to one of them, it will also be perpendicular to the other. The converse says if I have two lines that are perpendicular to the same line, that means the lines are parallel. So basically, if you got parallel lines and one's they're perpendicular. Just perpendicular means parallel, parallel means perpendicular. Slope is defined as the rise over the run, and you can remember that because you have to rise before you can go running. Okay, you have to get up before you go run. Rise is the change in y. So the change in the y values, that's not, over the change in x. In math, change is symbolized with the Greek letter delta, otherwise known as a triangle. And you take the second y and you subtract the first y from it. You take the second x and you subtract the first x from it, and then you reduce if you need to. Okay. So that's how you find slope. Does anybody need to see some examples of problems? Nobody wants to? Yeah? Okay. So if I have two random points here that I'm taking out of the book, I just call either of them x1, y1, x2, y2. It does not actually matter, and I'll prove it to you. If I do -5 minus -2 over -3 minus 6, minus negative is happy, so it's positive. So that's -5 plus 2, which makes it -3, and that's -9, and that's positive 1/3. Now, if I have the same points, and I decide that this is the second one's, doesn't matter. I can do -2 minus -5 over 6 minus -3. And now I have two happy people, so they're both positive. And I get -2 plus 5, so that's 3. 6 plus 3 is 9, 1/3. So it doesn't matter which set is the ones and which set is the twos. The thing that will mess you up is if you call this x1, y2, and you don't go in the same order when you do your subtraction. And the only thing that will mess up is your sign. But messing up the sign on the slope is a really big deal. So we have positive slope. And we read left to right, and positive slope goes up as we move left to right. And you have negative slope, which goes down. And you have a slope of 0. So the slope actually equals 0, and that's a flat. That's not flat. That's a flat line. And then you have an undefined slope. Undefined. And that one goes straight. Pretend that's straight up and down. That one goes straight up and down. We have some slope postulates. And we have one about parallel lines. And we have perpendicular lines. The slopes of parallel lines are identical. Okay, so if one line has a slope of 2, will be parallel to the other line with a slope of 2. Okay. If you have an undefined slope, it will be parallel to another undefined slope. Okay, so when you have parallel lines, they're the same. If you have perpendicular lines, you have opposite reciprocals. And an opposite reciprocal is opposite sign and upside down. Okay, so if we're talking about a slope that's 3, it's going to be perpendicular to negative 1/3. Negative 2/3 would be perpendicular to positive 3/2. 1/2 would be perpendicular to negative 2. Undefined is perpendicular to 0. Okay, so we have types of equations. The slope-intercept form is y equals mx plus b. M is the slope. B is the y-intercept, which is the point 0, y, whatever that is. And then you have the point slope form, where m is again the slope, and the point x1, y1 is some point somewhere on the line. It can be any point. Slope-intercept forms of lines, no matter what point you use to find the equation, you'll always get the same exact identical equation because you find the y-intercept. If you're using the point slope form of a line, the same line can have an infinite number of different equations that'll look different because it just depends on what point you pick. But if you were to convert that to the slope-intercept, they'd all look the same. Yeah. So this will stay a y, this stays x, and then this is some number, and this is also some number. And that number comes from whatever point you're using. And then you have horizontal and vertical lines. Okay, horizontal line is flat like this, right? And these are always going to be of the form y equals some number. And this number is going to be where the line hits the y-axis, whatever number that is. And then a vertical line goes straight up and down, and these will always be x equals some number. And this number is where it hits the x-axis. So if you've got a horizontal or a vertical line, you don't need to go through all of this to try to figure it out. You just look at where it's hitting the axis, and if it's hitting the y-axis, it's y equals. If it's hitting the x-axis, it's x equals. Okay, the parallel postulate. If I'm given a line, and I'm given some point that's not on the line, so okay, I'm given a line and I'm given a point that's out somewhere else in space, then there's only going to be one line through that point that's parallel to the line I had. Only one. Any other line I would try to draw through that point would not be parallel. It would intersect somewhere. That's the parallel postulate. Okay, so the perpendicular postulate is very similar. It says if I'm given a line, so we'll still keep our same line, blue, and I'm given a point that's not on the line, then there is exactly one line through that point that's going to be perpendicular to that given line. Only one. Okay. These are our types of triangles. Acute, all angles are less than 90. Obtuse, one angle is more than 90. Right, one angle is exactly 90. And then equiangular, all angles are equal and they all equal 60 degrees. Equilateral, all sides are the same. Isosceles, two sides the same. And scalene is no sides the same. You can mix together acute, obtuse, right, isosceles, and scalene. So I can have an acute isosceles, an obtuse isosceles, a right isosceles, or an acute, obtuse, or right scalene. What I cannot mix is the equiangular and the equilateral with anything else. These go together. If you are equilateral, you are equiangular. If you are equiangular, you are equilateral. Those are together. Now, technically, these are also both acute, but we don't really say acute equilateral. You just say equilateral. Okay, let's add something here. If I have a triangle, no matter what triangle I have, all angles in a triangle add up to 180 degrees for any triangle. Okay. And then we have this special exterior angle thing. If I have an exterior angle, it equals the two interior angles on the other side. for all triangles. Let's start with midpoint. The midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And this is an ordered pair that you get. Okay. Now, if you remember, we had to find an endpoint given the midpoint and the other end. And I gave you kind of a non-algebraic way to do that. So you do 2 times the midpoint minus the endpoint. And that gives you the missing end. And again, these are all ordered pairs. And then you have the distance formula. Okay. First, you do the subtraction. Second, you square it. Third, you add it. And finally, fourth, you square root it. Okay, so that's the order you have to do things in. Subtract in the parentheses first, then square both your answers, then add those two together, and then take the square root of whatever you got. Yeah, we can do an example on the distance. Let's say I want to find the distance between 2, 3, and 6, negative 8. Okay, so those are just 2 points out in space, and I'm going to find out how far apart they are. I'll label them, and it doesn't matter which ones are the ones and which ones are the twos. Just you can't mix a 1 and a 2 in the same parentheses. So then I'll do the distance formula. So I have x1 minus x2, and then y1 minus y2. Okay. This becomes 3 plus 8. So I'll have the square root of negative 4 squared plus 11 squared. So that's 16 plus 121. So that's 137. And since that's not a perfect square, I can either leave it just as the square root of 137, or I can do the actual decimal. And it's going to give me 11.7. I'm rounding, but so that's how you'll do that one. You have a triangle. You have a base and a height. The height is always perpendicular to the base. And you can either say area is 1/2 base times height, or you can say base times height divided by 2. Whichever one you like better, it's the same thing. The perimeter is add all the sides. You have a square. All the sides are the same length. So the area is side squared, or side times side. Perimeter is the side times 4, or you can just add them all up. If you have a rectangle, you have a length and a width. So the area is length times width. And the perimeter is 2 times the length plus 2 times the width. Or you can just add up all the sides. If I have a circle, I'm going to do the radius in blue. And I'll say the diameter is red. So radius goes halfway across, diameter goes the whole way across. The area is pi r squared. If you have the diameter, you divide it by 2 to get the radius. Okay. The perimeter is actually called a circumference because a circle doesn't technically have a perimeter, it has a circumference. And it is either 2 pi r, or if you have the diameter, it's just pi d, because there's no point in dividing d by 2 so that you can find the radius, so that you can then multiply it by 2 again. Right? That's just extra steps for yourself. So if you have the radius, you use 2 pi r. If you have the diameter, just pi times d. And pi is either 3.14, or if you're using fractions, you can use 22 over 7. But most of you guys probably would rather use the 3.14. So this is a rectangular prism. We're going to use any prism. Oh, that's what's wrong. I've got two. Okay, hold on. Let me fix that. I don't need my cone and my thingy in the same box. All right, so for any prism, the surface area is going to equal the perimeter of the base times the height plus 2 times the area of the base. So P is perimeter of base. And B is the area of base. Okay, so depending on what shape you have, you'll have to go back and use the area formula to find the area of the base and the perimeter of the base. Now at this point you don't have the formula for the area of a hexagon or anything like that. We haven't done that yet. So you'd have to be given that to solve this problem for surface area if you were given this hexagon. So they would tell you the area of the base of a hexagonal prism is 20 and the height is 5. So then find the surface area. So you'd put the 20 here and the height there, and then maybe they'd tell you the side length, and so you'd have to find the perimeter. Okay. The volume is the area of the base times the height. Now in a rectangular prism, so a box, the volume is length times width times height. So if you have a box, you just multiply length, width, and height, and you have all your numbers, and you've got your volume. If you have a cone, the surface area is equal to pi RL plus pi r squared. And L is what's called the slant height. And that's this length right here. The height that's at a slant, not straight up and down height, slanted height. Okay. And of course radius is in here. And the volume is 1/3 pi r squared h. And that's the regular height, which goes up the center like that. Oh. Also, volume is always in square units. Or sorry, surface area is in square units, volumes is in cubic units. So square inches, square feet, cubic inches, cubic feet. If you have a pyramid, the surface area is equal to 1/2 of the perimeter times the slant height plus the area of the base. So P is perimeter of the base, L is the slant height, and then B is area of base. Okay, so again, this is L right there, this height right here. The volume is 1/3 the area of the base times the height. And the height goes straight up and down the center. So that's to the, like this. If we have a cylinder, the surface area is equal to 2 pi RH plus 2 pi R squared. Radius over here, height is the height of the can, or whatever it is. And then the volume is pi R squared times the height. And then if you have a sphere, the surface area is 4 pi R squared, and the volume is 4/3 pi R cubed. And then R is the radius from the center of the sphere to anywhere on the outside.